what are the different features available. You try to process it and give us a result, right? And then it will, on the basis of the certain feature like shape or color or proximity in terms of the distance and all, it will be able to give us the results. Okay, so that's how we provided. This time we did not give them, like in supervised learning, we were giving the labels. This time we are not giving labels, and it has given us the different groups. Like it has separated the hexagons, it has separated the rectangles, and it has separated the circles. That's how, guys. Okay. So once we understand that what is supervised learning and what is unsupervised learning, then we also saw like what is a semi-supervised learning. Mixture of the data, amount of the label data set. Let's say in this case, we are giving the red dots and blue dots, and we are trying to identify on the basis of the color here. And we're also giving some plain data set, which where we are not given in what are the different labels, or let's say color in this case. Then machine learning algorithm is able to process this data, and then the basis of the data which was labeled one, we try
Because I think it's a good time to start.
Okay. Hi guys, and welcome back to day 3 of our series of machine learning, deep learning, NLP, and computer vision. Hope I am audible to everyone. Right? Just quickly confirm and just you are able to see my screen, right? Okay. 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 Okay, guys. Thank you very much. And then let's start with the recap till now. Till day 3, what we have covered till now is we started with understanding what is artificial intelligence, what are different approaches in artificial intelligence, what is difference between human intelligence and artificial intelligence, right? Then we started have a look at the how everyday life is affected by the AI, what are some amazing use cases of the AI, and what are the limitations. Then we started with looking at the machine learning, how machine learning is different, how deep learning is different, are they integrated with each other, who is support of whom. And with that approach, we started with understanding the machine learning. Then in machine learning, we understood what is machine learning, what are the popular approaches, what are the three major tasks that machine learning algorithm performs, like regression, classification, clustering. And we also tried to visualize, right? We were also able to visualize the algorithms, and we were able to understand that what is the background, how supervised learning works, how unsupervised learning works, reinforcement learning in background, how they performing the calculation in the background, how is the distance calculated, how predictions are performed, and how classification is different from clustering, how the different clustering algorithm works upon, how they try to cluster without having labeled data, right? And then we were able to understand what is the complete roadmap in order to become a successful machine learning engineer or deep learning engineer, right? Deep learning engineer we'll still try to understand, but at least we are clear with the part that what is the complete roadmap for the machine learning, right? So today we will try to focus on what is the complete life cycle. First of all, you will ask that, okay, we understood what are the popular algorithm, what are the major tasks, but what is the everyday life look like for a data scientist, right? What are the tasks that he has to perform? In order to understand that task, we have to first understand what is the complete life cycle of the machine learning process. Once we understand what is the complete life cycle, how the journey of this entire machine learning model starts, from right from the inception till the deployment. So once we understand that, then we will be able to actually gain some insight that okay, how was the algorithm performing, how data is taken, how the cleansing is done, how the visualization parts are performed, and once we deploy that model again, is it complete, or we still need to take further more action in order after deployment also. So how the performance evaluation even after the deployment does, and what is retraining, then all these concepts we try to learn, go through slowly one by one and try to understand. And I will make a code walkthrough, guys, today. Today's session going to be super important because we will probably try to end machine learning today, and we'll try to start with the deep learning. And before we end, we'll actually go through the code, and I will make a walkthrough through the code for two amazing use cases of the machine learning, and how actually machine learning work in production grade. Two projects we will make a walkthrough, so you guys will have a complete feeling like how the algorithm works, how different calculations are performed, how data is taken, how model is built, and after model is built, how performance evaluation is done for the model. Okay, guys. So I hope you guys are clear with the agenda, and then we can proceed further. Just guys, put in some comments in the chat box that whatever we discussed till now is clear, and we are good to go. Okay. So I hope you guys will ping me fast. So without further delay, we'll try to understand what a data scientist does. What is the role of a data scientist? You guys might have also heard about the now it has become a talk of the town. Like whenever you guys are seeing the job description across different job portals or different platforms. So there are certain popular terms which are arising nowadays that like machine learning engineer, data analyst, data scientist, data engineer, or say NLP engineer, deep learning engineer. So we'll try to also unbox this concept that how is data engineer different from machine learning engineer? What is the job of a data scientist? What is the job of a data analyst? How machine learning engineer is different from the data scientist? Okay. First, even before we start, we try to understand that what are the tasks that a data scientist person performs. Okay, if you look at the left hand side of the graph, I have created a person like me who is a data scientist typically, and how his life look like every day. Okay, what are the major tasks we perform and how much percent of the work is how much percent of the time is dedicated to what kind of task. Okay, so let's start understanding that whenever there is a machine learning task or a use case which need to be solved, so it start with the data, guys. Okay, first we start with the data. Okay, we try to collect the data from different intelligence portals which are available in the organization. Maybe it is in terms of the CSV file, or maybe it is in terms of the database, maybe it is in terms of the JSON, or different formats which are available. So entire thing is collected into the structured or unstructured data. Let it be for just for the understanding purpose, we'll start with the structured data. First step will be collecting the data. Okay, so 19% of the time person spends in his life is to collect the data. What do you mean by collect the data? That whatever data which is generated in the organization, it is stored in some form of databases, right? Or some storage facility will be available. Let it be any facility where the Microsoft product or Oracle product or some certain other ERP applications which are generating the platform and the database application which are used. In spite of all of that, we need first step. What we need is to understand where is the data. Once we understand where is the data, we have to apply certain techniques to get this data into our application where we will be performing, which will be the playground for a data scientist. So first thing, what data scientist will do is to collect the data. So 19% of this time is gets involved into the collection of the data. Once we collect the data, we just cannot directly go ahead and apply a model, right? So once we collect the data, we need to understand whether the data is available in a certain format or not, whether data is complete or incomplete, whether data quality, how about the data quality, whatever available data is there, is it good to go with the model, or do I need to perform certain actions so I can clean the data, I can bring it to certain acceptable format so that my machine learning model can learn and it can deliver the desired result. So second step will be, once we collect the data, then we will have to start analyzing the data or cleaning the data. What do you mean by analyzing or cleaning the data is, and guys, if you see, out of entire task, 60% of the task is time is dedicated to cleaning data. You'll say why? Because see how machine learning model works. It's completely based on the data. If whatever, see, it's simple, right? Whatever things we are feeding it to the machine learning algorithm, it will try to predict according to the data only. If we are not consider the enough patterns or proportion in the data, then our machine learning model will have a limited insights in this data, and it will be try to predict according to the present data. So we whatever data is there, we have to ensure that data is in a certain acceptable format. Acceptable format means there are no missing values, right? There are no LM values. If there are any values or missing values, then our model may be not able to understand the entire pattern among the data, right? So what we have to do is we have to understand each and every column, whether the date format column is there, whether the categorical variables are there, whether there are numerical variables are there, whether there are missing values. Once we see all these missing values, numerical, categorical variable, let's say if there is a date column, and instead of this date column, someone has put in mistakenly certain other information, let's say some other numbers. So it is not acceptable, right? Because machine learning will try to understand that, okay, this column is a date and it has to perform something related to date. Maybe it will consider this date column in order to bifurcate the data. Let's say we are doing a self forecasting. Obviously, we will have to look at a certain pattern of the data for the specific point of time, right? If my date column is not updated or having certain missing values or some absurd values, obviously machine learning algorithm, whenever try to split the data or try to consider a certain amount of data for a certain specific period of the time, then we'll have issues, right? So certain certain information may be missing because of this incorrect data values which are available in the column. Similarly, if it is a categorical variable and we type to categorical variable means it's a variable which is having the certain text values, like, or say categories, gender, let's say gender or type of account, or certain values regarding whether this is a this particular a category falls into the certain other categories, let's say fashion category, or we are going to look at the customer shopping data, then we will be obviously having the category that which category the person is performing the shopping, like whether it's a fashion beauty category, or whether it's a grocery category, whether it's electronics or some other category, right? So if that information is not up to date, then obviously our machine learning algorithm will not be able to perform as robust as is expected, right? So that will be second part. Then we have to also see that if there are any weird values which are present. Weird values in the case that if I see that my category unique values in my category are, let's say, 30. Entire my categories are having only 30 type of unique values. And if I see any other values other than 30, so obviously it is a mistake, right? So yeah, it's a mistake from the business insight side, but machine learning will model will not be able to bifurcate. Whatever available categories will be there, it will try to take and predict accordingly, right? So again, it's a kind of a misclassification also, which could be also a result and which could lead to a incorrect predictions, right? So we have to ensure that whatever categories are provided are up to date. Whatever data is provided is not having any errors or missing values or outlier in the case. Outlier means the value which is very weird from the normal range. Let's say if I have a, let's say I have a data which is pertaining to the income of the people, income per person, and I've seen that the range of the income per month will be lying somewhere between 30K, right? Between 30K to, let's say, 3 lakh, right? So if someone puts in 3 crore, it's possible, but usually whenever in general scenarios, if I know that whatever customers I have are lying between 30K to 3 lakh rupees per month, and if I have a certain values, maybe 5 or 10 values, which says that the income of certain person is up to 3 crore, that means it's an outlier because it's a far away value, which is very different away from the range, right? It will be somewhere here, very away, 3 crore, right? So if I try to predict accordingly, it will be obviously when I try to take the average value, it will completely give me a misleading average, because what is average? I am trying to find out what is the center, okay, between the mean value and the max value. Between mean and max, if I'm trying to find the center and if my max value is mistakenly given as a 3 crore rather than which should be within 3 lakh, obviously my estimation of the center will go somewhere here, right? Rather than taking within this limit, my center will be shifting. Once I think the center is shifted, the entire interpolation of the data will go wrong, and my model will not be able to give a desired result because of this outlier, right? So that's how, in simple terms, guys, because there are many certain techniques in order to understand what is outlier. Outlier, you can simply understand it is a value which is far away from the normal range. Okay, so this kind of manipulations you will be doing while cleaning the data, right? Missing values, treatment. Okay, if you find that using, I'm mostly saying missing values. So how we gonna feel the missing values? We try to understand what is unsupervised learning, right? In unsupervised learning, we try to bifurcate the data into different clusters. So let's take example that I have bifurcated my customers data into certain categories or clusters. Within that cluster, whatever customers are falling, maybe they might inherit to a certain particular values, right? Which is a mean. Okay. If I bifurcated my value of the income, let's say I am taken the bifurcation on the basis of the income category. So what are the income categories and how the customers are falling into different income category? On the basis of that, if I try to perform the clusters or different categories of the income, or maybe low income category, medium income category, high income category with giving particular range, and super high category, right? So if in between low income category, obviously I will have certain values, right? Certain values, and out of that certain values, let's say some certain data points having certain missing value information. So what I can do is I can try to understand what is the mean value in that particular cluster, and I try to apply that mean value for the missing values. So what I can do is I can just replace the missing value with the mean value, right? And maybe it is not that accurate, but at least it will try to get a certain amount of information which will look very realistic, right? So at least this way I can fill in the NA values. If it's a category value, then I can fill it with the mode. Or if which is a very small amount of data, let's say entire in this cluster, very small amount of data is lying, which is having certain missing values. So maybe I decided to remove that data completely, right? So I can remove that data completely in order to make the data look complete, right? The quality data. So it is as simple as that. If you are able to feed a quality data, obviously you will get a quality results. So that's how. Okay. Once you do a data cleansing or say, so data cleansing will also include, guys, looking at the column and looking at the graphs. Okay. So I will try to understand what, let's say, if I have 100 columns in my data set. So I have to also understand whether all these 100 columns are useful in order to predict, right? In order to build a model or predict. First question I will be asking whether all these 100 columns are necessary. If all these 100 columns are necessary, or can we reduce this 100 column to certain up to certain limit, let's say by 50% or 40%. So I will be left with only 50 columns or 40 columns, which will again help me to get the similar information which was provided by the 100 columns, but without impacting the pattern or without impacting the information. I am trying to bring back the data into, or try to fit the data into 50 columns, right? Like, let's say we can merge certain columns together, or we can drop out 3 or 4 columns and we can combine and make a new feature out of it. So in this way, we try to make sure that whatever columns are available, are they first question is, are all of them important? If important, can we try to merge them? If they are not important, or let's say certain columns are related to each other, like we understood yesterday, correlation. Okay, if certain columns are correlated to each other, let's say this is column X and this is column Y, and both the columns I can see that there is a certain relationship. As the X grows, Y is also growing. That means what we can decide is, out of taking all these two features, we can take one of them and try to build a model. It is also possible, because in end of the day, they are trying to explain the variation in the data the similar way. Even if I choose one of them, it's okay, right? So this way we can also try to understand the correlation between the data, whether all the columns necessary, whether we can drop certain columns, are the columns up to date, how we can make sure that we are reducing the dimension. Why this is important? Because first of all, we have to visualize the relationship. If I am trying to visualize the relation between 100 columns and I am trying to visualize the relationship between 50 columns, obviously it will be easy for me or for machine learning model to understand 50 column rather than trying to understand or draw a pattern between the 100 columns. That's a simple task, right? Because you guys will also be looking at the certain graphs. Like in this case, we are looking at this spider web graph. And in this graph, you are seeing, at least you are able to see the 2D or 3D graph. Beyond the 2D or 3D graph, your mind will not be able to understand, right? What is going on practically. So it is very difficult or ambiguous to analyze in such a way that we have to bring the relationship in between the columns and try to visualize the relationship so we can draw pattern also. And then machine learning model will also try to understand the pattern. And mostly the machine learning algorithm works on the distance calculation, like we've seen in the classification. Okay, whenever we are looking at a classification algorithm, we are trying to see that if there are two kinds of data. Okay, these are the two kinds of data which are available. I am trying to draw a line and try to bifurcate data class 1 and data class 2 mostly, and also depending on the distance, whether they are near to each other or not, we are trying to understand whether these fall into certain category or not. So obviously most of this machine learning algorithm will be working on the distance calculation. At that time, we have to also understand that if I am trying to perform a distance calculation among 100 columns and I am trying to perform a distance calculation among the 50 columns, there also be a computational cost around it, right? So my model has to be scalable, right? Whatever model I am building, it should give me the result, very accurate result, plus it should give me a timely result, right? So in order to understand that, we have to also understand all the dimensions are necessary. So that's how, because a lot of processing is done here. That's why 60% of the time machine learning or say data scientists will be spending on the data cleansing, because this is a major task, guys. Because see, entire our prediction lies on the data, and this is the crux of the entire life cycle. If I have a quality data, then only I will be able to understand the pattern. If data is not up to mark, or we have a suboptimal data, obviously the machine learning algorithm prediction will also be suboptimal. So we cannot expect to perform it according to the expectation, right? So that's why it's a huge and a very important, super important task that we try to focus on the data part mostly. So whether data is complete, whether data is up to the mark, It is whether it is in a proper format, whether it is trying to convey the relationship between the data, whether all the columns are necessary or we can bring down the data. And once we try to see the data, when we can visualize the data, try to understand certain patterns on ourselves. There are also business logics which are also important and plays the critical role in trying to understand the data. If you have a domain knowledge and you try to understand very easily that, okay, this particular column is of no use when we are trying to achieve. Let's say we are trying to take a example in case of the online customer platform where they're trying to make a targeted marketing. At the targeted marketing column, obviously they will not look at the religion or gender. Okay, I'm just giving a pseudo example, guys. Okay, they will not try to look at the religion or gender. Okay, mostly it will not make any sense because it is a human being and they are to purchase in certain categories. That doesn't make any sense. Look at the religion of the person, right? I'm just giving weird example, guys. So maybe we'll try to understand more detail when we go into the life cycle. So maybe certain other information is there, like what is the height of a person. It doesn't have to do anything with the spending. Height of the person or weight of the person has nothing to do with the spending of the person or his purchasing capability, right? Certain examples, or whether the person belong to certain region or belonging to certain let's say certain region, or say in certain country or certain geographical location, has nothing to do. Yeah, it will have an impact majorly when we try to look at the Western world and Asia, but I am not saying in the Asian world, within India only. If we try to bring a customer prediction model, we'll try to look at the let's say West Maharashtra. Within West Maharashtra, most people will have a similar kind of environment or similar kind of predictions. So they will have their spending habits maybe likely to be common, right? So that's how. So we have to also understand whether these regions are impacting or not and all these things. And then based on that, certain business knowledge, okay, I have a business knowledge, and according to the business knowledge, I can say certain columns are important and certain columns are not important. So accordingly, I can make a decision whether I am going to keep all these features or not. So that's how this is very important advice. Once we know we have taken a data, and then we will try to analyze the data, we clean the data, and once we clean the data, we try to perform the visualization. Once we perform the visualization, okay, we decide. So next task comes is the feature selection. Okay, like say feature or let's say column. That what are the final columns which I am going to consider out of these 100 columns. I will try to select certain columns, which may be 50 columns, which are giving me enough information, or it's enough for my machine learning model to understand and learn. Then I can perform a prediction on them, right? So once you take these things and try to understand, then we'll try to understand according to the business case, what are the algorithms available, right? What are the different algorithms which comes to the using of the machine learning algorithm. So according to my business situation, I told you what are the major tasks. Either we are doing regression, we are doing classification, or we are doing clustering, right? So if my problem pertains to regression, then I will have to find out that what could be the possible algorithm which I can apply here in order to solve this situation, right? So maybe it's a regression task, maybe it's a classification task, or maybe a clustering, or whether it's a big mix. So first I will do with the clustering. Then once I perform a clustering, then I will try to perform the classification on the clustered data. Okay. So that's what we have to understand. So that's why they are given very less time. 4% of the time, people will choosing the algorithm. So once we choose the algorithm, we'll try to build the data, right? We'll try to build the training data. Let's say out of my entire data set, let's say I have taken entire data, 100 rows. Out of these 100 rows, I will not entirely provide this data to the machine learning algorithm directly. What I will do is I try to do a test trend split. Out of these 100 data points, I will try to make a bifurcation. Let's say 80% of the data, I will give it to machine learning algorithm, and 20% of the data, I will keep as a validation set. Why? Because if I give an entire data set, so my machine learning model will be knowing all the scenarios, and it might have learned all the scenarios. So if I provide a new data set, maybe it will perform very well if I provide out of this 100 data set. But if apart from this 100 data set, if I provide him any real-time data, obviously that machine might not have seen that data. So it is more possibility that machine learning model will fail. If I am providing entire data set, it is limited to entire data set. So what usually we do is, rather than giving all 100% data to machine learning algorithm, out of available data, we try to make a split. Out of this split, we try to provide only 80% of the data to the training the model. So building the training data. Once we build this 80% of the data, we try to train the model. Once we train this model, we try to look at the remaining 20% of the data and we'll use it as a validation data. So this out of 20% data, we'll try to test this model on this 20% of data. We'll try to analyze how is the performance. Okay. Yes, guys, trace data. Yeah. Validation data. Okay, guys, sometimes what happens is people try to split data into the three categories. Trained data. Okay. Let me clear this. It will be better to understand. Sometimes usually what happens is depends on also it's a choice of a person who is building machine learning algorithm, also practice of the machine learning algorithm. Usually data is split into two parts. One is 80-20 or maybe 70-30. Okay. 70-30. Again, it's depend entirely on the business situation or what kind of data is available. If usual split will be 80-20 or 70-30. But sometimes people what they think is if I split my data into the three parts, right? Just in order to make a more precaution, I will first split it for train. Okay. I will split it in train. Let's say 70% of the data I will give it to train. Then I will keep 10% of the data as an validation data. Okay, 10. And out of that, 20% I will keep it for test. So this is also possible, guys, keeping the data set. Because what I will do is I'll train the model on 70% of the data. I will perform a validation test on the basis of the train. And once I perform a validation test, and if I can see that my model is able to perform, I will again expose my model to this 20% of the data, which model has not seen as a test data in order to make the model more robust. And accordingly, I will perform the split and then try to build a model and check the accuracy on the test data. So this is also possible, guys. So usually people try to split it in the two parts, or maybe in certain cases they try to split it into the three parts, like say train, validation, and test. So it's also up to you guys also if you are able to get the accuracy accurately, even splitting into two, train and test, or you can splitting into test or validation, train and validation. It's okay. It's up to you. Okay. I hope I answered this question. How to clean data manually in Excel or EDL. Okay, guys, we'll talk about all these things. I'm just trying to give overview, like how we do Excel and all. We can look into it. But overall idea here is to try to understand that in data scientist or a life of a data scientist, what is the major task? What is the major task he will be performing? So 60% of times he trying to, 20% he try to perform, get the data in desired format. Once we get the data, we try to make it in suitable quality, missing value treatment, visualization. Then we try to make a trainable data, and then we try to build the algorithm. Once we build the algorithm we train, then we'll try to evaluate, generate the insights. Okay, guys, that's how the entire cycle will go. I hope I made this very clear to you guys, that how this life cycle works. We'll try to understand more detail, like when I will make a code walkthrough, that how this life cycle is happening and how we are cleaning the data and everything. But just to get the understanding or overall idea that how the things are working and where is the most of the times data scientist spending his time. So that was the main aim behind this. And then obviously the most important task is now these terms like ML engineer, data scientist, and even NLP engineer, right? Now saying we want to hire an NLP engineer. So how they are different, NLP engineer, or I want to hire computer vision scientist, right? CV, or some people are saying we want the person who is able to work on the generative AI. Generative AI, right? You might have seen generative AI. So what is the generative AI, computer vision, NLP, how it is different from data scientist, data analyst, machine learning engineer, AI engineer, right? We'll try to understand these things now. Before we proceed, guys, just give me confirmation that you guys were able to understand how much amount of time a data scientist will be spending on what kind of activity, right? So I hope I made this clear to you guys, that at least you will be able to understand that what are the major tasks what a data scientist will be performing in day-to-day life, right? So just couple of confirmation, guys, before we start to understand what is data engineer, machine learning engineer, and how it is different, or what is NLP engineer. Hope you guys were able to bifurcate the task, and what is the important task, and how much importance you give to the data cleansing, how is the machine learning building techniques taking time, and how is the bifurcation for the entire life cycle. Right, okay, we are having a question from Mr. Reddy, that whether the validation is fixed, whether validation is fixed or dynamic throughout the training. Okay, guys. Okay. It works like that. What happens is, first we try to train the data. Okay. Once we train the data, then what we do is maybe we try to test it. Once the training complete, then only we will try to test it, and testing may be performed into two stages. One is on validation data, and second will be on the test data. So to answer your question, sir, validation is not fixed. It's also depending on the situation, because some certain organization may try to do a testing directly to the users. When you build a data, you try to perform a validation on the data, and you try to deploy that as an, let's say, testing phase, or you can say as a beta model or alpha model, which is still in testing but not of the complete features. So what we do is we try to perform usually the UATs with the users. Okay, so we do a UAT with the user, and by doing the UAT, we try to get the different scenarios from the people, that how the model is performing, and then we try to do a final test on all the set of characteristics of the data, and then the final model will be deployed for the entire public. That's all. Okay, how do we select validation? Okay, validation, it also depends. Once you are train a model, you can choose validation, immediately try to understand, because first, once you train a model, then you need to understand whether my model is up to certain mark or not. So for that purpose, first we do a validation. Once we do a validation, at the time, I think I will be able to answer all these questions when we'll actually do a code walkthrough. But just to tell you that validation is possible at any point of time. But before performing any validation, we have to train the model. Once we train the model, then only we try to analyze its performance. Maybe it's to validation. Then we try to launch it with certain feature, and we try to do UAT. Then we try to do a test on entire characteristic of the data or entire features, and then we deploy it finally to the production system. So that is also possible. It's depend on the different deployment strategies which are companies having. If it's a product based company, obviously they will try to have it. If it's a SaaS based company, and they're providing this software as a model to the any other company, obviously they will perform all this validation among themselves. Then they will try to deliver this model to the person who is using your software as a services. If you are having a company which is already providing a product to the customer, and then out of this product, your machine learning model will be a small part of your microservices, then you try to launch this along with your regular product, and they try to take a UAT directly from the user, and on the basis of the success of how the UAT goes upon, you try to launch the entire features in the next version or next patch. This is how it happens. Okay, guys. People are asking that what is the difference between validation set and test set. This is Kavita, I think. Ma'am, it's there is no difference. Okay. So usually you can say, as a precaution or as a rigorous testing, what I am doing is it's up to a policy that how organization try to validate the result. If I want to do a rigorous testing, so I will do it in two parts. One is validation, one is test. So, but the data which I am keeping for validation and for the test will be different. Out of this 100% data set, I will have a 70% of the data for the training. Then I will dedicate some 10%. It's also, the percentage also depends, guys. You can even take 20% of the data, and then remaining 10% of data you can also take for the test. Okay. And then if you want to perform, you are not sure about it. Let's say you are performing a very complex task, and accuracy is the utmost importance in order to deliver your product. So your model should not go fail. Let's take example, you are building a product in the healthcare which will be able to detect a cancer for a person. So in order to solve this use case, what will be important? The quality will be important, right? Here, the competition speed will not be important. May be important, right? Because if you are providing any certain input and you are getting an output after 1 hour and half an hour, obviously this is not acceptable. But if you are giving an input, let's say X-ray for this case, okay, this is the X-ray you are providing and you are expecting a result whether there is a cancer, okay, so cancer or no cancer. Okay. At that time, I just cannot make mistake, right? My model has to perform with at least more than 98% or 99%. 98% I'm saying because just to be realistic, right? There may be certain unseen scenarios or certain scenarios where it could go wrong. But what I am expecting here is I should get with the highest, my priority will be for the accuracy, right? So my priority will be high accuracy and competition speed will not be that much of priority. It will be priority, but it will be a second priority. At that time, what I can do is I can do a rigorous testing. So I will try to split it into 3, or maybe I try to do a cross validation. In cross validation, what we do is cross validation, guys, again, it's a different technique. What we do is, let's say, let me draw it properly in order to understand what is cross validation. In cross validation, we try to set a number of iteration I'm taking, let's say value of k-fold. K-fold cross validation is a popular technique in order to perform the testing. Okay. In k-fold, I try to understand like how many folds I want to take. In this case, 3. I'll take an example of 3. In this 3 case, what we'll do is I take first iteration. This will be my first iteration. In my first iteration out of this entire data set, what I will do, I will try to bifurcate my entire data set into 3 parts in first iteration. Because my value of k is 3, I will train a data on this one part and I will try to perform validation on the, let me take the different color. You try to understand. So this is my validation. First part of the data will be training. This will be validation. This is training. And then third part, what I will keep is for testing purpose. This is my first iteration, yes. Okay. In first iteration, I'm trying to take a split in this way. So next time what I will do, whatever training data I have covered here, whatever data points which are available in the training data set. Okay. These data points which were available in the training data set. This looks like this. In second iteration, what I will do, in second iteration, I'll make training data somewhere here. Okay. This new data set. I am trying to split it in 3 only, guys. Okay. But first time what I did is I took this part. Okay. This part, first part of my data as a training. I trained my machine learning model on first part. Then remaining part, I kept it as a validation and as a test, right? In second iteration, what I will do, and I'll try to calculate the accuracy accordingly. Okay. So I have to calculate the accuracy for this first iteration. In a k-fold cross validation, what we'll do is second stage, since my machine learning model has seen this part of the data, so rather than exposing this part of the data to the machine learning model, previously whatever data I have used as a test, I will try to make it as a training data set, this part. Now my machine learning model will, whatever the test data was there, my machine learning model will be trained on that data. And then I will keep these remaining 2 parts as a validation and test. So you getting, guys, what happened is whatever data points which were not covered in the training data set, maybe there is a probability that they will also get trained. Now machine will get also trained on this data part, which were available here, but our model was not able to see this, right? So similarly, we try to calculate accuracy here. Let's say our accuracy came as a 96%. In second iteration, again it increased because it has seen again the third part of the data, which was not previously given. So we tried to perform test. the accuracy will increase, obviously, because it has seen even more data. Now, in third stage, what we'll do is, now whatever remaining data set which it has not seen was the middle part, right? This was the middle part which it has not seen yet, right? In third iteration, we'll try to train model on this part also. And then we try to make a testing on the remaining parts, right? Test and validation. So first I try to train my model on first part, and remaining two parts, I divided data into three parts. First, I try to train it on first part, and these were not exposed to them, and I prepared the test cases, I prepared validation and test, and I try to measure the accuracy. Then what I did is, whatever data was exported, I hid this data in second iteration, and I tried to propose the data which was not seen, one part of the data, second part. And in third iteration, I will try to expose the data which was not seen in the previous two cases, and then I will try to perform a validation in this test case. This set, what we are doing is, in this process, we are doing 2 to 3 iteration, and also in 3 iteration, we are trying to train a data model on different data sets, on different scenarios. So in this way, my model, I'm doing testing at, and this time accuracy will definitely be increasing. So or if you try to perform more also, maybe possibility that it will go down also because of the overfitting. We'll try to understand in different cases later on, because our major focus will be on the deep learning here. So, but just to give you intuition that even if you try to make it more, it will reach to a saturation point, and maybe accuracy will decrease also, which is possible. So we have to take a optimal, right? In this case, this 3 iteration, optimal iteration, because if you try to run a similar data, maybe possible that the accuracy may go down to 90%. Maybe overfitting happens. Okay, so this is also possible. So it's again depends. Like we say, in this case, we're trying to detect a cancer by passing X-ray, just simple X-ray. We're trying to detect whether there is a cancer or not. So this is very super important accuracy. Accuracy is the utmost importance here. So I try to make a rigorous testing using the K-fold. So that's how, guys. I hope I made it very clear, because every day I get a chance to become part of the testing. In this does this is done cross validation, right? Okay, guys, right? Cross validation. I hope I answered this question when I tried to explain these things, right? The cross validation. I hope you guys were able to just give me confirmation, guys, that I was able to give you a proper explanation that what is cross validation, how rigorous testing can be done, whether we should take validation, what stage we can take validation, right? So just ping me, guys, in chat box, so we can go ahead and try to understand. I hope that I usually thought that I will give a overview, because but you guys are so much interested that we are going into the very deep part, like how the actual validation and all going on. But it's good part. So but we have to also look at the time frame, and then we have to cover the topics also. So I think I will go through. Okay, yes, I am happy that I am able to explain you guys that how cross validation is done, and how the validation is performed, how rigorous validation can be performed. So let's move to our next topic. Similar topic, that what is the difference between the data engineer, machine learning engineer, data analyst, and data scientist? Okay, guys. Yeah, guys, there are other validation techniques also apart from the K-fold, that is leave one out, or normal trends 10 test splits also. But now this is not the topic for the day. So maybe it's possible that you perform other validation test tasks also. It is there. So you can get into more details when we'll talk about entire things. Okay, thank you, Ayush, for the compliment that I'm able to teach you correctly. So that's my job, right? Okay, guys. So further, without wasting the time, let's move to the things that okay. So nowadays the HR thing, even HR are more confused that nowadays every day there is a new talk of town. Like let's say now the today talk of town is a generative AI engineer, or you guys might have heard prompt engineer, right? Prompt engineer is a new job description which has been introduced in today's right? Prompt engineer. Prompt engineer. Prompt engineer. What is prompt engineer? You guys are already aware, right? That we are using chat GPT like models, which are the generative AI model. Why generative AI model? Because they're trying to generate certain, let's say, they're trying to generate certain, you can say, how we can put it is like, let's say they are trying to generate some response based on your intent or your query, right? So that's why they're called as generative AI. Usually what happens is in deep learning, we can discriminate the deep learning into two parts. Okay. If I want to discriminate the services of the deep learning, one is discriminative. Okay. One is discriminative. In discriminative, what we're trying to do is I am trying to perform a task where I am trying to discriminate the things. Let's take an example of image classification, right? Image classification is the first task. So in image classification, I'm just providing the image and I'm trying to ask whether this particular image belongs to certain category or not. So I'm trying to classify it, right? Classification. Classification is done, right? This is discriminative. In second thing, what I'm doing is I'm providing, let's say take example of this person. I'm providing this example of this person. I'm trying to say that, trying to find out, not this person. I'm trying to provide this entire frame where I have collected a picture of eye, a picture of certain machines, a red circle, squares, right? And this database picture. If I provide this entire picture, then my machine learning model should be able to identify or should be able to find out the objects among it, right? So that is called as object detection. So when I pass this image, my model should be able to should give me that, okay, there is a person available. Okay, this is a person available. This is a database available. This is again one disk or certain, let's say circle available. Out of that, there is an eye available. Okay, and there is also this kind of picture is available. So what I'm trying to do, I passed the entire picture, and out of this picture, I'm trying to identify the different object like person, this one or this. So this is also trying a kind of a discriminative analytics or discriminative computation technique, where I'm trying to identify the different objects. Okay, these are the different objects I'm trying to identify these objects, right? So this is one of the things. Then, or maybe you pass an image or video and you trying to track certain person. In this case, we're trying to, let me clear this. Okay. So we can try to understand. Once we understood now what is classification, right? We understood one task will be to classify. Second task will be to object detection, OD, right? Object detection. Just pardon me for this handwriting because I'm not able to write it correctly in the notes. Okay. So first, discriminative. What we trying to do is we trying to analyze the services which are provided by the deep learning into different tasks. One is discriminative, one is generative AI, right? So in generative AI and discriminative, we're trying to understand difference. So in discriminative, if I am providing any image data set or any video, what I'm doing is I'm trying to bifurcate or try to classify it, like maybe image classification. I am Vikas, whether it is a cat, whether it is a dog, either a bus or car, and so on. So this kind of image, I provide an image and it will be able to bifurcate me into the certain categories like cat, dog, animal, car, and so on, right? This is one task. Out of that, then second task will be to, if I provide an entire picture, okay, or entire picture like this one picture, and out of that picture, I should be able to bifurcate the different object like human, eye, right? This square box, the disk, this database and all. This is object detection, guys, right? Object detection. The second task will be the object detection, right? Second task will be object detection. And then third task, once we detect the object, then third task will be tracking, object tracking. So let's say I have provided you an image or a video, and out of that image and video, I have to track a face of a person, right? Once I track this face, using this bounding box, so with some accuracy and all, it will be able to provide that, okay, this is Vikas. Okay, and Vikas. And if it's a video, that if I'm moving here or moving this side, so this continuous bounding box should be there and it should be able to track me whenever within this frame, whenever I move. So it should be able to identify my face, right? So that is called as tracking. Okay, that is called as tracking. So what we can do is we can also perform tracking, right? So again, is tracking is nothing but what? It's also discrimination, right? Tracking. I'm trying, sorry, handwriting is not that correct. But at least I will try to put an initial word so you guys will be able to understand what I'm talking about. So object detection, then we are doing tracking here. Then we're trying to do classification, object tracking, then there's also pose estimation techniques, or you can say advanced technique, where if I provide this entire frame, okay, so out of this frame, I will be able to identify the face, and after I identify the face, I will be able to give you the coordinates, key points, facial key points. Okay, it's called as facial key points, FK. Facial key points. Key points like where is my nose? What are the coordinates for my eyes? Left ear, right ear, forehead, right? Out of that, four eyelids. Then where is my upper lip? Where is my chin? So this kind of coordinates will be provided in terms of the JSON format. ChatGPT is like usual, or is it like a bot which can generate questions? Yes, guys. ChatGPT is, you can say, it's kind of a bot, humanoid bot, which be able to understand your question and able to answer it, right? So what we're talking about is, once I know the tracking, object detection, and classification, it is all comes to, or it is a pose detection, pose detection of facial key point detection. Okay, this is one of the things where I will be able to get the coordinates. I will be able to locate a person in this entire frame. In this frame, I will be able to understand where is the face, and out of face, I will be able to give a key points like where is my eye, what position is my eyes there. On the basis of that, we can have a use cases. Like what could be the use case, guys? Can you just guys come up? Like I have identified in the picture, I was able to identify a person. After identifying a person, I was able to identify his face, and out of this face, I was able to look at the coordinates. So can you guys can imagine what could be the probable use cases once I able to identify these coordinates for this image, right? What could be the probable feature and real-time applications which I can able to solve using the coordinate? Any ideas, guys? Just put in some ideas in the chat box so we can start discussing it further. Come on, guys, quickly put in whatever comes to your mind, that if I am trying to locate a person in the image, and after locating a person, I'm trying to locate a person's face, and I'm trying to get a coordinates from all of them. So what could be probable use case I can solve using this? Kid movements, correct. Sudhir, correct. What else, guys? What we can do? Can differentiate whether male or female, correct? Yes. What else we can do? Come on, guys. My chat box should be filled. Should have filled now with the different responses. Come on, guys. Quickly. Patrolling. Yes. Patrolling. We can identify. How we can identify patrolling? Yes. Patrolling is possible when we trying to identify a person only. But after even identifying a person, we're trying to get it to face and trying to find out the coordinates. So what I can do with the coordinates, guys? If I try to look at the eyes activities, right? Person wear a mask or not? Correct, ma'am. Kavita, ma'am, yes, correct. This was the use case which we implemented, right? During the COVID, whether this person is wearing mask or not. If this coordinates, with the basis of these coordinates, if I can see this, his mouth is covered with a mask or not, his nose is covered. Validating means to judge the nature of the person. Yes, correct. We can judge a person, but how we can judge a person? If I am able to identify key points, I'm able to identify a person. Or what could be real scenarios, guys? Like how we can do this? What you can do with these coordinates? By body gesture, correct, right? Guys, simply if I am getting the coordinates, right? Body gesture, language, yes, ma'am. Identify whether he is lying based on his facial expression. Okay, you have come up with very deep application, but I'm yes, it's correct, very accurate, right? Whether he's lying or not. But look at the simple example, guys. What you can come up with the facial expression? What could be the simple expressions you try to analyze? Simple expression. What are the simple expression or emotions we try to understand from person's face, or looking at certain key points in his right? Emotions we can identify whether he's happy, right? whether he's happy, whether he's crying. If he's obviously crying, then obviously his eye movements will be different. Whether he is laughing, then obviously his mouth will be wide open, right? Now, whether if he's sad, then his mouth will be right, not open, that much open, and his eyes will be also might be closed, right? Maybe not that wide open, right? Or his facial expression of the cheeks, or maybe eyes or ears. There will be differences, right? Whenever there are certain emotions, there will be differences on the basis of that, right? What I can say is, especially if I know the coordinates, then I can calculate, guys. I can calculate the golden ratio. Have you guys heard about the golden ratio? ROI is also possible, yes. Golden ratio, guys, GR, golden ratio. Have you guys heard about the golden ratio? Anyone? Just quickly, guys. You know what is golden ratio? Anyone who is aware of what is golden ratio? Quickly, guys, just ping me if you know golden ratio. What is the golden ratio? Where we try to apply this golden ratio. I will wait for 1 minute, then we can continue. I will start with golden ratio. I will give you time. So you guys can ping me what is the golden ratio and what will be the real implication of this object detection, right? Golden ratio, no one heard. Golden ratio means, in my words, to gauge the person. Yes, maybe gaze to person, but there is more to it. Golden ratio consists of different 6 ratios. I will give you a hint that there are different 6 to 7 ratios which are calculated. Mean ratio, no, not mean ratio, but ratios is like, I will give, it's related to the beauty of a person, right? I'll give you a hint that it's related to the beauty of a person. So we're trying to understand look at the face and trying to identify about the beauty. So to identify the criteria of the beauty, we're trying to apply these 6 ratios. Okay, it's something related to that. Whosoever may be able to understand correctly, maybe he will get a reward. Okay. Come on, guys, quickly. Anyone who's aware of the golden ratio? How golden ratio is calculated? Yeah, beauty language is there, but anyone who can come up with what is exact meaning or what is the implication of the golden ratio? Yeah, ma'am. Yes. Golden ratio is applied. Ratio is 1 to 1.68. Yes. Okay. It's a distance value. Yes, correct. It's a distance value. Okay. Okay, guys, we have to move ahead. So I will quickly start with what is golden ratio. Golden ratio, what it means is, it's a number that shows up all over your body. Yes, correct. All your body. But in general terms, if I say, okay, right? In general terms, if I am trying to say golden ratio, in golden ratio, what they do is they try to, okay, let's make it a bit clear. Space, so I will be able to understand what is the golden ratio. In golden ratio, what we do is we try to take a ratio between the coordinates. Let's say his forehead distance, and we try to divide it with the distance between this nose and the upper lip. This one ratio, or we try to find out the symmetry, that how much is the symmetry for a person length and arms, legs divide. No. We are just looking at the face, not towards the entire body. Okay, facial expression, correct. So what the golden ratio says is that how is your face is symmetric, whether your face is more symmetric towards the mathematical calculation. Let's say if whatever face you guys are having, whether all your if I try to divide them in a half part, okay, my face, so whether this right part will match to left part or not. Okay, right or left, from your point of view, it will be vice versa. Okay, if I try to divide my interface in half, so it should look very similar. So that means you are symmetric, right? Your proportion of face is symmetric, right? Whatever distances, or the distance at which your eye is kept, right eye is kept, left eye is kept, or ear is kept, or your upper lip is there, the position of the upper lips and the entire you can say architecture of your face, if I try to divide it and try to fold it in between, so it will not overlap, it will exactly fit. Your eye will fit on this eye, your ear will fit on this eye, your head and your forehead and head, and also your neck, and also maybe left cheek or right cheek, everything is symmetric, right? So if that's called as golden ratio. And in golden ratio, we try to collect the different ratios, maybe forehead to distance between your upper lip and the nose, or between your chin, okay, between your chin to lower lip. Okay, this part between your chin to upper lip. This kind of ratios. What is the difference between the right eye pupil to your left right eye pupil to right ear, or left eye pupil to left ear? Then we try to take a ratio of them. Okay, this kind of things, right? Okay, guys, this kind of amazing things we can happen. And also there is a publication which comes in every time where they try to publish the report that in the world what are the beautiful places according to the golden ratio. So that's how it's a criteria of the beauty measurement, guys. And that could be the amazing use case which you can solve during the using this deep learning. So what we were talking about is what nowadays there is a new term called as prompt engineering. Why it's coming is it's because of the chat GPT. Okay. Chat GPT's application, human-like application, is try to understand your context and give you an application. Okay. So chat GPT. And that is with chat GPT. Okay. I'm talking about chat GPT. Okay. In chat GPT, you have to throw some question and it will be able to solve the question, right? Understanding your context in this language, right? So this can this could be also possible. At that time, the entire deep learning was divided into discriminative and generative. Out of that discriminative, we try to understand what are the bifurcation of the discriminative. We try to classify the image. We try to find out the object of the image. We try to track a person, or also it is possible tracking that we try to detect the pose. Okay, that if I am trying to detect a pose, maybe I will be able to try a skeleton. And on the basis of that, I have to try and find out the coordinates. That at what coordinates my right toe, left toe, elbow, okay, my hand positions, elbow positions, my shoulder positions, where is my chin position, where is my head, whether my head position is completely straight or whether it is leaned. Okay, I'll use a different color. Whether my position is completely in 90 degrees or whether it is lean forward or lean backward, right? This kind of things I can track using the pose estimation, and then I am able to use some amazing use cases. Maybe try to when you try to predict the emotion, maybe you see that person is in aggressive mode, so his hands position will not be like this in the relaxed mode. So maybe it is upward move position, right? Your leg position, or maybe whenever you pass a video to a machine learning algorithm or your deep learning algorithm, it will try to identify your walking speed, right? Which is a use case we were able to solve, because if you have any certain disease or dementia, obviously a person walking speed will be interrupted. He will not be working fluent. So looking at your video only, guys, we will be able to identify whether you guys are having any disease or not. And this kind of use cases, amazing use cases can be solved. So what we are doing for that purpose, we try to find out the pose. What is the pose of a person? And on the basis of the pose, we try to find out different calculation angles and between the key points in JSON format. Okay. And the basis of that, we are trying to come up with the application. That's how. In generative AI, what we doing? Are we generating anything? Obviously, we are calculating anything, but we are not generating anything, right? And generative AI says about whenever I try ask anything, he is able to generate something for me. Like let's say, I am giving a text. Okay? I'm giving a text as an input, so he will be able to provide a counter text to it. Or if I am giving a text, you might have heard. So he should be able to give me a speech out of it. Right? I have provided text and he will give me an audio. If I have provided text, so it should be able to give me the video, right? Text to video, text to, or I can simply say, okay, I want to generate a picture. Let's say I want to generate a picture, very artistic portrait, and I am providing some description for that portrait, right? And if I am providing some certain description for that portrait, right? I'm providing a in text format, certain criteria, and I'm asking my model to generate picture out of it. So it's also possible, right? So if I am providing any unstructured data means image. Okay. I'm providing any image, I'm providing any video, I'm providing any text, and out of that, it's providing me a certain result. So that is called a generative AI. In generative AI, usually what happening is, whenever we are trying to create something, but model which is lying in the background, chat GPT like model, which is called as a large language model, it should be able to get correctly, right? So in order to get correctly what are my requests, these requests are called as prompts. So whatever queries, let's say in terms of the normal database language, if there is a database and trying to access a database, what we do is we write a query, right? English like language, we write a query. Sorry. I write a query, right? We write queries, okay, and fire this to database, and we get the result back, right? Maybe rows, tables, columns, spreadsheet, right? So similarly, if I am trying to work with the chat GPT or large language model, I have to provide a commands, right? Commands in terms of the language, okay? And that language or commands will be called as prompts. If I provide a correct prompt, then only my machine will, since my machine is trained on the prompt styles, right? So I'm trained on the prompts. If it says that correctly, okay, chat GPT, give me a presentation, beautiful presentation at what is AI and what are limitation of the AI. So here what happening is I'm telling what is AI. So what are the keywords, what and AI, right? So in background, this chat GPT model is trained on these keywords, and these keywords pertaining to these keywords, you try to understand the intent. Once you understand its intent, you will be able to give you a result according to intent. So even just to create this kind of intent of the queries or commands, this is called as prompt. Okay. So there is a new job called as prompt engineer, where you are able to create a chat GPT like models, and you are creating different prompts. Okay. We'll again go into detail like what is prompt, how generative AI working, what is chat GPT, what are the architecture behind it, and how this is done. But why I'm coming to this topic, guys, because nowadays, coming back to the same topic, that nowadays in the market there are different job description which are available and how they are different. So we talked about generative AI, prompt engineers. Prompt engineer means what? Whatever query type languages which I am able to write, or user will be able to write in English, and you should be able to get an accurate result out of it in terms of the image, video, picture, or music, anything, right? So that kind of language understanding and that working on that kind of architecture prompts, it's called as a prompt engineer, because prompt engineer has to work from the human side also. That is called as reinforcement learning, guys. It is also part of the reinforcement learning, RLHF, reinforcement learning, human feedback. Okay, reinforcement learning we already talked about, with reward and return thing, and human feedback is that actually when you're talking with a human, so human will be able to do an interaction with a machine, or human to human interaction. So at that time, it will have an intelligence, certain emotions, certain set of criteria through which it will be able to communicate. So what they do is actually they are thinking from the human point of view. So as a human, what human will be able to ask different scenarios, that kind of scenarios will be created for the machine, and it will be used along with the reinforcement learning, and the model will be trained. That's how you will not be able to even bifurcate whether this chat GPT is a humanoid robot or whether you are speaking to a robot, right? Because you're trying to get a human feedback, and on the basis of human feedback and reinforcement learning, it will be able to learn everything, right? So that's how. So our main aim behind this slide is to understand, so what are the different jobs available in the market and how they are different to each other. So especially when it comes to AI, a common thing is data scientist. Okay, what is the job of the data scientist? In order to understand the data scientist, I have created certain key areas like deployment, MLOps, key factors, right? Data pipelines, database, data visualization, storytelling. That means again visualization, right? Business insights, reporting. We are creating reports, right? Statistics and experimentation. So these are the factors which are taken into consider. This is the okay, guys. Just for the disclaimer, I am not an author of these slides. Okay. This slide is very popular over the net nowadays, and this slide was able to explain the people very accurately that what are the job differences or type of jobs which are available in the market, so you guys can be ready accordingly. Okay, so that's why we are trying to understand these jobs and this job description. Okay, simply start, or let's say we can start. I was able to tell you guys that what are the key factors we are taking. Whether my job is to create a data pipeline, whether my job is to write a query and get information from database, whether I have to create a data visualization, whether I have to create a dashboards or reports or something like that, which will be called part of the storytelling, right? The way we are doing right now, I'm trying to teach you a data science, and when I'm trying to teach you a data science or machine learning, I'm trying to make a use of the pictures, right? So in terms of a story, I'm trying to explain these things to you guys, right? So that's how, whether this is my job or whether my job is to just to build a model, I have to choose different machine learning algorithms and I have to apply it. and whatever accuracy comes in, I have to provide this model. Okay. Or whether my job is to understand the stats concepts and apply it to the data which is I am taking, or whether my machine learning modeling I already talked about, or whether my job is to whatever models once is created after the training, I have to deploy it to cloud, right? I will draw a cloud here just for our understanding. So whether my job is to create the application, once I create application, whether my job is to deploy this model, right? You guys can understand deploying this model. I have to make this model available in the cloud so other users can access to the cloud. Okay, that is also one of the job, guys, which data scientists will be performing, but not exactly data scientists, but the machine learning engineers. So that's, you guys are clear like what kind of jobs or key factors I'm talking about. Just give me confirmation at least. Model deployment, data visualization, data pipeline, data cleansing, right? Model building, statistics, applying statistics to the data, or creating reports out of the data, and whether it is a combination of all. Okay, that's what we are trying to understand over here. Just guys, quickly just ping me in the chat box that whatever key factor we are trying to analyze, the job description is clear to everyone. What are the key factors we are discussing? On the basis of this key factor or services, microservices, we're trying to analyze the different job sets. Okay. Just couple of yes or no's, guys, so I can just further take it further quickly. Just ping me your response, guys, fastly, so we can understand now. Go ahead. Okay. Yes. Yes. Couple of more yes, guys, so I can understand. Expression coming from. Few more years, guys. So I think we have more than 700 people who are joined in. At least I can expect a couple of more yes or no's. So we can go ahead and start without wasting the time. Okay. Okay, guys. Thank you very much for the explanation. So now I try to understand that what are the key factors we are trying to understand. What are the job description according to the key factors. So let's take an example of the data scientist first. In data scientist, if you look at the spider web, what it's saying, most of the times, this is your arena. Okay? So you will be performing this task more. There you will be guys doing also certain other tasks, but the percentage of that task will be very less. So if I try to understand for statistics, yes, mostly you will be doing statistics part. Mostly you will be doing machine learning modeling part. Mostly you will doing experimentation. Reporting part, yes, but not mostly, but not mostly, but up to certain extent. Storytelling, no, not that much. Data visualization, yes, there will be data visualization, because without data visualization, we will not able to understand the relationship, and then we'll not be able to build a model. And also database part, very limited part, right? Guys, if you say this database part, very limited liability will be there, because we have to just take the data, because there will be a separate job description or separate people in the organization. Whenever you work with the multinational companies, or whether you are working with the startups and all, so no one will be bombarded with all the jobs, right? You have to do everything. No, it's not like that. They have defined these roles in such a way that once you understand these roles, so you guys can prepare yourself accordingly, according to these terms, right? So data scientist, what he will do, whether my job of the data scientist is completely focused on the deployments, no, I use better one, different color. So deployment part, MLOps part, and data pipeline part, no. So if you look at this graph is hovering mostly towards the somewhat business insights, data visualization, but mostly into experimentation, statistics, and modeling, right? So that's how. So if you are saying you are a data scientist, then your part will be mostly divided in the applying the statistical model, mathematical model, machine learning model, doing experimentation on the model. And for that purpose also you will need a data. So you have to take a data. So how you collect a data is again a job of a different person, how you collect, because you will not be through with all the database which are available in the market, which are available in the company, or how you are not a SQL expert, guys. No one is expecting you to become an SQL expert or become an expert in the query language, right? But you should know at least the basics of the query language. If a situation comes in, then you should be able to manipulate data, or you should be able to pull the data from the database. That's what is expected. As long as you are able to pull the data from the database, then you are okay. You are good to go. Okay. Once you apply this database thing and get a data, then the real work starts, right? Data cleansing part, like even 60% of the times you do data cleansing, bring it to certain format, then you will build a model, train a model. then try to change the accuracy. Okay. So guys, clear what is the data scientist role? So data scientist role will most probably not include the deployments and MLOps part. What do you mean by MLOps part? MLOps part means once you create a model and give it to pass it to someone, after that, what will happen? How it will be consumed by an end user, where it will be deployed, how it will be made available, whether this model which you have created and passed it to the team or user, whether it is performing as per the expectation or not. What is if a new data comes in, because every day there is a new data coming in. And let's take example of the portal of customer portal or a retail company, but there are new recent trends are coming up or recent data is coming, recent products coming up, right? So eventually, if we create a model which was like 6 months back, after the 6 months, maybe there is a more fashion come out, more products have come out. So whatever your machine learning model was built, let's say 6 months back, may not be relevant to some current situation, right? So it need a retraining, right? So who will be responsible to do this retraining? All these tasks will be taken care of the MLOps. Just like the DevOps, there will be a separate teams who will be taking care of these things. And again, a retraining end-to-end model where we create a model. Once we create this model, we deploy this model. Okay. After deployment, we'll do a performance evaluation, whether this performing according to need, or if not performing, again, it will go back to the training. So that's complete cycle will be someone there. There should be someone, right? There should be someone who will be monitoring this entire life cycles, right? That's a job of a MLOps. So data scientist usually what you do, you try to retain a data, get a data, clean the data, right? Perform certain visualization. Okay. On the basis of the visualization, you try to understand, analyze the pattern, apply the machine learning model. And then once you apply machine learning, try to evaluate model whether it's performing with greater accuracy, and you pass it to other team. Okay. That's how the data scientist will work upon. Then try to understand what is data analyst job. If you look at the data analyst job, he's mostly working with what? Data analyst. Also, some people consider data analyst as a data scientist. Not correct. Right? Data analyst job is to again work with the data visualization, like ClickView, Power BI, Tableau, different business intelligence tools are there. Using these tools, they are creating a storytelling like reports, dashboards, and all, right? Through these dashboards and report, they are trying to gain insight or provide insights to the higher management, where they will be able to take a business decisions. Okay, so his job will be limited to this. He will not be able to make a machine learning modeling, right? Statistical concept, yeah, statistical concept will be there, not completely. Machine learning model, very less engagement will be there, right? So mostly his engagement will be the data visualization, creating reports, dashboards, storytellings, and right, and creating insights and reports so that the management can take the decisions accordingly, right? Attendance, yes, guys. Amar will be sharing the attendance, but still there is time, right? So we still have half an hour, so we can cover a lot many topics. So see, guys, clear what is data analyst? Data analyst is not as a data scientist, guys. Okay, data analyst is a different role. Then coming back to favorite topic, what is data engineer? Okay, how data engineer is different from data analyst? Because data engineer, what he do is he completely works on the data pipelines and the databases. So that's the job of the data engineer. What are the different databases is available, through which data different sources our company is getting data, and how to maintain these models and databases and all. And accordingly, so we try to perform some manipulation or managing the databases, how the ETL task will be performed, how the end-to-end data will be available for the disposal for the different departments. That's a part of the data engineering, guys, because they will not be building model. Yeah, they certainly they will be dealing with certain other areas, because let's say if there is a data scientist and a data scientist need a data, right? So he has to communicate with the data engineer, because maybe data or latest data is not available or something like that, or any issues with the data inside getting the data, right? So you have to coordinate with the data analyst, you have to coordinate with the data engineer, right? So that could be possibility. That's why they have kept a very minimum interaction or engagement with the team. But mostly data engineer will be working for the creating the database, maintaining the database, and making data available in a certain format to the disposal over the other departments. So this comes, but there is, guys, there's a huge misunderstanding between the data scientist and machine learning engineer, where people are using it as alternate to each other. But there is a difference, guys. What is machine learning engineer? What is the data scientist? Machine learning engineer, okay, completely focus not only on the machine learning building models, they also focus mainly on the deployment parts. Okay, and the MLOps part. They are using statistical modeling and everything, and they have a very less interaction towards the data visualization, towards the reporting. Okay, they'll not be creating reports and all. But yeah, reporting will be there. It is an internal part because whatever work you are done, you have to report it, right? You have to report, present it in a format that where your board members, your customers or users will be able to get an insight or able to know at least how to consume that tool. Or whosoever department is there or who's able to make an integration with the legacy system, you have to present that to them, right? That is called as representation or reporting. That's it. But whenever it comes to data scientist or machine learning engineer will also be working on the backend part, right? Like how we can deploy this model to a cloud, certain cloud or certain services, how this model's entire life cycle will happen, when training will happen, when the retraining will trigger, how it will look like, how we perform the evaluation of performance, how to keep a track of performance. So this guy, machine learning engineer, will mostly dealing with deployment, MLOps, data pipelines. Also, he's aware of the machine learning modeling and statistical part because he can also build this part. Okay, guys, clear what is the difference between data scientists? Data scientists will not do a job mostly because nowadays there are startups who are making a mixture of everything. That's okay. But in the mostly the sophisticated companies or multinational companies which are structured enough, so they will not be mixing up this criteria. So the whole idea behind this is to understand what is data engineer, what is data analyst, what is data scientist role, and machine learning engineer. Guys, I hope this made you guys very clear that what is the role of a data scientist, what is expected out of you, how many times, what activity you will be doing, how much efforts is spent on what activity and all, right? Guys, let's quickly just have a check that you guys were able to identify the different roles. What are the responsibilities, how much responsibility is required or engagement is required on which front. So just quickly just drop guys so I can have a some breather and so we can quickly go to the details of the life cycle. So we want to also discuss in next half an hour one use case of the machine learning. Come on guys, it's time to give a reply. So quickly just share with me your thoughts that are you guys are aware what is the job description of ML engineer, data analyst, data scientist, how it is different from each other, who is responsible for what. Okay, just quickly just drop in some messages guys so I can just get a confirmation. Just confirm guys and then we can move ahead. Are you guys clear? What are the different roles? How it is different from each other? Come on guys, just put in some. Please guys, I request you to drop in quickly messages. So at least we will be able to understand that whatever things I'm trying to explain over here, that you guys are able to understand it or able to follow it correctly. Okay. Feedback link will be shared, guys. Okay. Amar will be sharing feedback link. Attendance link and feedback link, Amar will share, right? Amar will share it in. Okay, guys, couple of more feedbacks, guys. Couple of just more yes or no's, so we can move ahead quickly. Already we have only half an hour left. Come on, guys. Just quickly send. Just quickly give me yes or no, so we can move ahead. I can see only couple of people are replying. Come on, fast. Data engineer responsible for managing and organizing data and also pipelines. Yes. I mean, organizing data and pipelines. Yes, correct. Who else, guys? Come on. Put in some efforts to post me. At least it will give me like a good feedback that I am able to bifurcate clearly between these roles. And you guys are aware that what is expected out of this. Data scientist analyze and get insight along the data. Yes, data scientist will analyze and get insights. Yes, data patterns. But data scientists mostly available for what? Building the machine learning pipelines. They'll not be responsible, maybe responsible enough if you go to a small startup, maybe they will try to teach because they try to get things done from everyone. So, but in multinational companies, there will be different departments for everything. I hope guys that I was able to clearly differentiate between these roles. So quickly, without wasting time, let's move to our next slides. So try to understand, like in this scenario, we'll try to understand, okay, different concept of what is model, what is feature. Quickly, within 5 minutes, we should be able to finish with this one. So what is model, guys? What is model? It's a statistical model or hypothesis. Let's say, what is model? So when I'm talking about the linear regression, what we're doing is we're trying to find out the values, continuous values, right? So at that time, I'm putting a model or framing a hypothesis that there is a relationship between y and x, and on the basis of this relationship, I'm trying to frame a statistical model, which is called as y equal to mx plus c, which is a equation of the straight line. So this is a model of statistic concept which I'm trying to put in over here, and on the basis of this assumption, I'm trying to predict the value of y on the basis of x. So this is a multiple, then we will have x1, maybe x2, mx2, and so on, right? Multiple features will be there, and xn, right? Xn and plus c, guys. So that's how the underlying belief or underlying model or statistical model which we trying to equation we use, that is called as a model, because on the basis of this equation or a model, it will try to predict values. When it comes to classification, again, it will be a straight line or parametric line or something else, on the basis of which it will be able to analyze or bifurcate the things or classify. Also, when it comes to clustering, it will try to calculate the distances. Okay, it will try to calculate the distance. On the basis of the distance, you can try to do the bifurcation or clustering. That is called as model. Okay, what is feature? What do you mean feature? Let's say if we look at this example, okay, in this column, I have created example of this data frame. In this data frame, we have different columns. Let's say person ID, gender, age, occupation, sleep, right? So these are the different columns which are available. And on the basis of this column, let's say this is my last column, BMI category, and I'm trying to predict this BMI category, whether I am overweight, normal, or obese in BMI category. So what I'm doing is, this is my Y and these are my X. Okay, all this my X and this is my target column Y. So you understood what is target column now? Target column will be what I'm trying to predict. This is my target. Whether I'm trying to predict a BMI category, weight, BMI category, whether I am overweight, obese, or normal. So that is target column. So features, again, these are the features, X column. Okay, on the basis of this feature or these columns only, I'm trying to predict Y. Okay, and then prediction. Once I am able to learn or provide this data, so my model will create a prediction, similar predictions, right? Like similar like this test column, and it will give me whether I am obese, normal, right, or overweight. So this kind of different predictions, which will be additional column, which will be provided on the basis of this. Whenever you pass any test data, it will be able to give you a prediction. So that is target prediction, and training is like in this entire data set, whatever is available with me, I will be passing to a machine learning model. Okay? And machine learning model, I will be passing this inside there, and that process will be called as training. Okay, and once I train, then whenever I pass any test data, okay, so it will should be able to give me the predictions result. So that's how training, feature, model, and target, right? You guys are now, I think, clear. Target is classical. Can be referred as feature. Yes, correct. Yes, guys, correct. So I think this is pretty clear. What is target? What is prediction? What is training? What is feature and model? So the guys, then comes the very super important content. What is overfitting and what is underfitting? In order to understand what is overfitting or underfitting, let's move to next slide, guys. And here this is an interesting, again, a very interesting, let's say slide. So using this slide, we're trying to understand once we fit a model, guys. Once you fit a model, whether my model is overfitted or underfitted. In first place, what do you mean by underfitted or overfitted? Okay, try to understand. Overfitting, or what could be overfitting or what could be underfitting. In some simple terms, when I say overfitting, means what? How will you pass it to model? Simple. Should this data be analyzed? Yeah. Data. Once we analyze data and everything, then only we will be able to pass it, right? So we'll provide just simple one command like model.train. Okay. We'll provide model.train and provide this data in terms of the vectors, okay, in terms of vector or data frame, and then that's how it will train. Okay? I create a model and then the model.train. In model.train, I will be able to provide the data frame which is available with me, right? And data frame in the bracket as a hyperparameter, and I also provide the split. Already did the split, like what is the train data and test data, and my model will get trained on this command, right? Once I provide this command to a model, I assign one variable m as a model, and then for model dot train, okay, model dot train, and I will be able to, with this command, I will be able to provide the training data. I hope I get. No. We'll not discuss. We'll discuss how we'll do when we do a code through walkthrough. But before we do a code walkthrough, what I want is you guys are very much aware of the concept of, you are aware of the job description, you are aware of the process. And if I directly take a code walkthrough and if I think this model is overfitting or underfitting or this model performance is not good, then you guys will get confused. That's why I'm trying to understand these jargons. Okay? These are very pretty common jargons which one should understand. Then only we will be able to make a walkthrough with me. Code walkthrough. Okay. So first of all, let's look at this slide. Okay. If I am trying to solve, what we discuss is there will be majorly three tasks. One is clustering, classification, and regression. In regression, what we're doing is we're trying to plot a data in x and y axis. Okay. This is my x and this is my y. On x and y, I'm plotted this and this is my data, right? And this is, if this is my data, and I am trying to predict y on the basis of the x, right? So what I told you that whenever we are doing a regression, in the background, one model is doing with plotting the data, and out of the data try to pass a line. If it's try to pass a line, in this case, if you see, trying to plus, we'll try to understand what is overfitting and what is underfitting from the graphical point of view also, and from the theoretical point of view also. Just to tell you what is underfitting, overfitting. Overfitting means my model is not performing well in the test data set. When I trained it and I did a test, right? I did a test. When I trained it and I did a training, after training, I tried to tested my model. At that time, it gave me accuracy, let's say 95%. Okay. It gave me accuracy of 95%. When I tried to make a prediction on the basis of the test data, it gave me a prediction of 90% accuracy with a 90% accuracy in the, okay, 90%. Make it better. So when I train data for training, okay, it gave me 90%. Okay. And when come to test, it fell down to 80%, let's say. So there is a huge difference, 10% difference in this. Okay. So that is called as underfitting. Okay. In training, it was able to perform very well, but it came to a test, it was not able to perform. That is called as underfitting. And vice versa, when we see that in training accuracy and test accuracy, there is a huge difference. But in training, it was not able to perform that good. But in test, all of a sudden it rose. Okay, vice versa. 90% in test and 80% test. Just from this simple point of view, guys. Don't quote me that this is exact concept. That concept will be somewhat different, but on a superficial level, we'll try to understand this concept. Okay. Whenever I'm trying to perform a prediction, at that time, what will happen is a test accuracy and training accuracy, there will be huge difference. Maybe less or more, or vice versa. According to that, the overfitting will happen. Underfitting or overfitting comes completely on that. Okay. Underfitting means what? And underfitting training, it is performing very good. In test, it's not performing good. Okay. In overfitting, what happens is, and overfitting, it is not performing as within a certain range or as per the expectation. Okay. We try to predict very with very high accuracy in the test, let's say 100% accuracy. It is not possible, guys. Whenever it giving you 100% accuracy, this is overfitting. Okay. In training, it was able to give 90%, and all of a sudden it's giving 100%. No model can give 100% accuracy, guys. That is wrong. Then means your model is overfitted. Then do go with the classification regression. Yes, guys. So understood, guys. Basic concept: what is overfitting and underfitting? Overfitting and underfitting, try to understand from the graphical point of view. Okay. From graphical point of view, let's say this is the data set which we have created. This is x-axis and y-axis. On axis is what we plotted a bend. And when what I said is in regression, what we do is usually we try to create a straight line or try to fit a line which will pass with the maximum data point. Instead of doing that, what we do is putting a straight line. We're putting a line which is going through almost all the data points. Okay, all the data points. I'm trying to cover all the data points, and then whatever accuracy I will do, we will be able to do 100%, right? Because I'm passing through all the data points, it will be able to easily identify the accuracy will be 100, which is wrong, right? We just cannot fit it in this way, right? So if I have to look at the shape of the data and I need to understand what is my shape of the data, we also spoke about the polynomial regression or linear regression, right? So if my shape of the data is like that I have to create a curve, I will, rather than simply, if I put a simply straight line, it will not try to pass through the maximum data points. In order to cover the maximum data points, I have to provide a curved line like this, right? So it try to pass through the maximum data points, and the difference between the actual data points and my prediction will be less. Okay, this is my actual data point and this is my prediction point. This is a different color for the prediction. Okay, this is my prediction. This is actual, so distance will be very less. So I have to try to fit a regression equation in such a way that it is very close to the data points, not going exactly through all the data points. If it goes to exactly one, it will give me 100% accuracy, let's say hypothetically, right? So it is giving 100% possibility, means what I'm just returning whatever data is available, I am returning as a prediction. So that's not possible, right? We are trying to fit a regression line. So we have to fit a regression line in such a way that, guys, that my model will try to pass through maximum line, so the actual and difference between actual and the prediction will be very less. So at that time, I will try to fit a polynomial curve here, because the straight line I am trying to fit, it will not fit it correctly, right? So underfitting, again same. When this format of this data is in such a way that I cannot fit in, instead of that, I am trying to fit a straight line like this. So there will be huge difference between actual value and the predicted value, right? So error will be huge. In this case, see, this is huge error because actual data point is far away from the prediction. But if you see this scenario, we try to almost accumulate, and the distance, whatever distance is here in actual and predicted, and the distance here, what is error, is less. Okay, that's clear. In regression, how the overfitting will happen. We try to fit a straight line. This is our main aim. We try to fit a line in such a way that according to the pattern of the data. If my pattern of data is such a way that I should not be able to fit a straight line, so I have to use a parabolic equation or parabolic line, which is called as a polynomial equation, polynomial regression. So I will try to fit a polynomial regression. Instead of fitting polynomial regression, if I'm trying to fit a straight line, which is a normal regression, so it will not give me a prediction. There will be huge errors. Okay, so that's how in regression it will happen. So similarly, if we look at the classification, guys, if my task is to classify the data. When I'm trying to classify the data, there are two classes. One is blue bars and another one is brown one. So in order to bifurcate, I have to again pass, if it's a straight line equation or if I'm using a linear classifier, I'll try to create a boundary, right, between these two. And at that time, I will try to able to bifurcate between two, right? So if I try to bifurcate between these two, then at that time, if I draw this line, obviously you will say, if I draw this line, there will be certainly some data points which will be present here in group one, brown group, which actually belongs to blue group, right? So these are called as outliers, right? These are outliers, but it's okay. So if I try to fit so the main aim to fit here is to make sure that I am able to fit a maximum data points in such a way that I am clearly doing a bifurcation. If I'm not able to do a bifurcation in such a way that I am trying to classify a maximum data point, then it will be wrong. Let's if we take a look at the first graph in classification, instead of doing this curve, what they're doing, they try to bifurcate each and every blue object into different categories. So by doing it, right, and they're trying to draw this curve. So they're trying to take exact each and every point, then try to fit a line out of that, and then they're trying to decide a decision boundary. Actually, which is clearly a overfitting because it is not possible. And usually it will, let's say, usually it will give you a very wrong prediction, right? So what or underfitting, what it is saying, rather than putting this polynomial line, which will help me able to bifurcate the correctly whatever maximum data points it. If I try to fit a straight line, okay, in order to classify the things, then what will happen is, if I see there are more and more number of balls which are available for the brown are got classified into the blue ball, right? And the one blue balls are less, but other brown balls, they are misclassified, right? The number of misclassification is more. Wherein in this case, we were trying to achieve 100%, which is again wrong. But here we were able to find a optimal solution where there are no misclassification or misclassification limited to certain percentage. Maybe we're able to achieve a 98% accuracy also. Okay, guys, clear? That's how it is done in regression or classification. If you try to predict in such a way that you try to fit a data classifier line in such a way that each and every object will be classified, this is again wrong. Okay, so we have to find an optimal solution through which we will be able to found a decision boundary. In this case, this one is correct. And in this case, we also able to see that we have to fit a regression, and because the pattern of the data in such a curvy way, we have to fit a polynomial regression in this case, and accordingly we have to choose the variable, choose the algorithm, right? So that's how it is called as overfitting and underfitting. In deep learning, what happens usually is, again, same thing. In deep learning, what we're trying to do is, we're trying to find out the train accuracy and validation accuracy. If train accuracy and validation accuracy, there is not much difference, because in theoretically, I said train accuracy is 90%, or validation or train, guys, we can consider anything else. So my final accuracy, which is test accuracy and training accuracy, if there is a huge difference, let's say 1900, there is a difference of 10%, which is not acceptable. So it should perform consistently with the trained data as well as the test data in reality, right? So if my model, if you look at the error rate, this graph of the deep learning, if you look at the first graph on number of epochs, as I go on number of epochs, increasing the iterations, okay, on the x-axis, the error rate is falling down. It is falling down onto certain limit, and after that certain limit, blue line is for the validation accuracy, and red line is for training accuracy. They are going hand in hand, right? There is not much difference. They are very going smoothly. So this is not this is the correct way. Okay. If there is a huge difference, say let's say in this case validation accuracy and train accuracy, there is a huge difference. That means it's overfitted. Model is overfitted. There is a huge difference. So my model is not giving a consistent predictions. Usually we can say in trained data set, because it is seen a trained data set is able to perform very well, and in test data set where it is not seen a cases is not able to give me a correct prediction. Simply that means this is how we can draw a conclusion, guys. I hope, guys, so you will be able to find out what is the misclassification, or you can say underfitting, overfitting, and balance fitting, right? So this is very clear. Yes. So guys, I think we have only 10 minutes left. So maybe we'll do a code walkthrough tomorrow for both the projects, and we'll start with the deep learning. For now, we'll try to consider what are the different frameworks which are available, right? Which in order to get a knowledge in the machine learning or deep learning. We'll discuss about the deep learning again entirely in the new class. So what is deep learning? What are the neural networks available? What are the approaches, and how the basic neural networks are one? And we'll try to fit in one neural network, which we will create our own neural network, and we'll try to solve a problem using that neural network, right? So before that, even due to the limitation of time, actually I wanted to explain the project and make a walk through the project, but because of the time limitation and the discussion got more intense, so I am not able to give justice to the code walkthrough. So maybe tomorrow we'll take a live scenario and do code walkthrough, but before that, in 10 minutes, let's have a certain topics which we can cover in 10 minutes. So obviously, when we are trying to perform a machine learning topics, we have to understand what are the different libraries or frameworks which are available. Okay. So in order to understand this, let's have a look at this one. In machine learning, guys, we'll be mostly working with the NumPy, okay, scikit-learn, matplotlib, scipy, seaborn, and pandas, and pytorch. Pytorch will not be using that much, but because still I am included, because whenever we are trying to solve a machine learning problem using the neural network, at that time we'll be using maybe Keras, TensorFlow, Keras, and PyTorch. So what is NumPy, guys? let's try to understand each and every package, and I will try to give you a certain brief of the package. NumPy is again a mathematical package, guys, which will we be able to use it with a certain functionalities in order to manipulate the data. So NumPy, what it does is try to take the different data which is available in the column in the form of the n-dimensional array, okay, and it try to perform them different calculation on the array. What kind of calculation? Maybe you try to transform the data, try to find out the different statistical measurement, or we try to transform data from, or we try to perform the matrix calculation or certain other mathematical calculation which we are able to perform. So all that mathematical application will be done by the NumPy. Okay, and pandas is again, guys, very important or super important topic. In pandas, what we'll do is just like the in pandas, what we'll do is pandas is super important package, guys. Whenever we're doing a machine learning, at that time we mostly dealing with the structured data or the table or data frames. Okay, in data frame, we have what we have to do is what kind of operation we have to perform is out of entire data frame, maybe we are selecting certain column, because you are seeing we are trying to bifurcate data in terms of the label column. Whatever label column is there, we'll give it to the machine learning model separately, and for the other columns which are the feature column, we'll try to take the separate data frame out of the entire data frame and try to feed it to machine learning model. So this kind of operation are perform using the pandas. Or what we can do is we can just like the SQL statement, we can out of entire data set, we can select certain columns and we try to find out or find out the relationship between certain columns. Some certain statistical significance calculations can be done, like what is the mean, what is the max, what standard deviation, variance of available, what are the missing values, how we can treat the missing values. All this calculation we can do perform using the pandas. We can do a group by, we can do we trying to find out the multiple. We can take out submerge the two data frame into one. We can melt the data frame. We can create different data frames out of one data frame. What kind of manipulations we want to perform with the data frames and the spreadsheet, which are available in the machine learning model for the disposal of data will be done by the pandas. Okay, and then we will have a very super important package which is called as scikit-learn. Scikit-learn is a package which gives us a pre-build all the algorithms. Whatever algorithm we are seeing for the supervised, unsupervised, or let's say semi-supervised reinforcement learning packages, all the implementation available in the scikit-learn. From the scikit-learn, we have to install the libraries, because you will not be able to write a code and then create this, right? You will not be able to create a code from the scratch, like how we perform a linear regression. So they have created these libraries and they have been put into this framework, which is called as scikit-learn. So we can directly call this library, let's say linear regression. We can assign this model of linear regression. We pass the perform some parameter tuning, and we can create the model. Similarly, for logistic regression, random forest, or whatever model, supervised, unsupervised, KNN, or all these models, and also the performance evaluation criteria, guys. We have to check the accuracy, we have to check the R score, so we have to check also confusion matrix or AUC score, or what is the area under curve. All these scores are the accuracy measures, error measures. So all this implementation is available in the scikit-learn. So again, guys, what we say is 60% of the times we are performing data visualization and data analysis. So for that purpose, we have this seaborn and matplotlib. Seaborn is an advanced statistical package, guys, on the basis of the basic package, which is a matplotlib, using which we will be able to perform different visualization. Let's say different kind of graphs. Let's say we will try to provide the histogram, or try to provide the pie charts, or bar charts, line charts, scatter plots, or correlation plots, right? Or box plots, or different kind of visualization which are available. We will be able to plot it, and on the basis of the simple plot, also using the seaborn, we can do an advanced visualization, like say 10 graphs at a time we will be able to view, or we can say we can take a target column, we try to put this target column against the features, and we try to visualize them into a single graph. That kind of visualization will be done through the seaborn, right? Correlation matrix, how to find out the outliers and everything that can be done, right? For web development, guys, I told you that whenever we create a model, we will require a framework through which we can create an API or something, some sort of framework using which we will be able to dispose this model for the users. Okay, how you created a model, you created this model in Python, you used R libraries and everything, and whatever things you have done in the Python, right? So you in Python web editor, you will be performing all these things. But when this things or model is ready for the prediction, how the end user will be able to achieve that. For that purpose, there are different web development or web frame applications which are available. So let's say popular one is Flask or Django, guys. So mostly we are using Flask for the purpose, but Flask is not for the production purpose, guys. Whenever we are creating some certain models, so in order to understand whether model is performing or not, so we are using a Flask application, or using a Flask, we are trying to create a REST APIs, RESTful APIs, which will be able to provide a graphical user face through which we can imagine that you as a user, and you're trying to grab this model and try to find out the prediction. At that time, using the frame Flask application, you will be able to create a GUI or ASA UX, and through this UX, you will be able to input the data to the model, and then in the background data modeling will happen. This model will be loaded, and it will be able to give a prediction. Whatever prediction is given will be fetched to the user's screen, right, on the web interface, right? And that's how you will be able to see. Let's say you are trying to predict a BMI, so you will provide a certain columns in the user interface. Let's say kind of chat box, which will appear in that. It will have a text boxes. In the text boxes, you will be able to give a different values which will ask, and in the background there will be a model which will be running. In the model will run and give you a prediction, and that model prediction will be fetched to again a user interface, which is a web interface, and where the image will be displayed along with the results. Let's say what is your BMI or what is the category BMI will be given. So you will not be able to understand what is working in the background, but in order to user, he need not to understand what is happening in the background. He just has to consume it, right, accordingly. So that's how the web application will be helpful, right? And once you do a web application, you can do a testing of your model through the API testing, and then we will be able to deploy it. Once you are able to create a web development, then only you will be able to deploy it, guys. So that's how the web developments. There are popular web development which have done Pyramid, Falcon. Falcon is another application which is a portal which is used framework for training the large language models, right? So we try to understand again. We talked about the visualization pandas. Python is there. You guys know already Python. Jupyter Notebook, guys. Okay. Jupyter Notebook is also an application using which we are able to perform the modeling. We are trying to execute each and every cell within Jupyter Notebook only, so we don't have to wait till the end. So we create an entire application and then you try to test it. Whatever few lines of code you are trying to create, you can test it directly there and you can see the result. So that's how Jupyter Notebook can work. SQL we spoke about. Then NumPy, Pandas, Matplotlib, Seaborn. Also, these are the visualization packages which are available. Keras and Keras and TensorFlow is advanced framework which will be used where we can create a neural network and solve our machine learning problems. In order to create the neural networks, we have a high-level API of the TensorFlow, which is Keras. Using the Keras modeling, you can create a convolutional or normal neural network, artificial neural network. You can pass the data. You can create an entire structure of the neurons and everything. What will be the layers? How much layers will be available? Everything, and how you are trying to see a prediction. So that's how the Keras will help you, right? And similarly, TensorFlow also you can write, but the writing in TensorFlow is somewhat complex. So you will be using the Keras. Right? For your image processing also, whenever we are trying to learn the deep learning techniques also, at that time OpenCV is there, Mahout is there, okay, scikit-learn image is there, using which we can perform a manipulation. Like we spoke about the facial recognition and taking the expression at that time also, we saw that how we can perform a certain operations, so that these are the popular libraries which are available, right? For this photo. I hope you guys were able to get an insight like what are the popular packages which are available and how we can use them, right? Beautiful soup. Okay, guys, beautiful soup is also an important topic, because whenever we are trying to it's an important library because whenever trying to solve an NLP problem, at that time we need to understand the unstructured data in the kind of text. So using the beautiful soup, you can use a web scraping. It can be used for web scraping or scrappy for that purpose. So you can directly go to a Twitter, and using the Twitter, you can analyze the data of the tweets, and you can try to bring those tweets into your database or data frame using the pandas. Once you in order to get that tweets, you can use Scrapy or Beautiful Soup to scrape the data from the Twitter. Once you get this data, so we can store it using the pandas in the data frames, and then we try to apply the machine learning algorithm, NLP algorithm, so we can understand, okay, what is the sentiments or what are the certain use cases which are available, right? So these are also important topics. So we already spoke about scikit-learn and everything which is used. So guys, I think we will try to stop here for the day because again to coming to the process of the entire machine learning and to making a walkthrough will take time. So what we can do is we can conclude this session here. I hope guys you guys have enjoyed this session because I was able to tell you different scenarios, graphs, and where I was able to explain you guys that how machine learning use, what are the different job roles available, how the deep learning is working, somewhat insights on deep learning, and entire. I think we have covered entire machine learning concept apart from the actual life cycle. That life cycle and along with the let's say implementation, real use cases could work through. So hope guys till now everything is clear and you are good with the concept. So guys, I would like to conclude the session for now. And we can stop here and we can start again tomorrow with the code walkthrough and we'll directly start with the deep learning. Thank you very much, guys, then, and see you tomorrow. Bye. Hope you guys, everyone has marked the attendance, guys. Don't forget to mark your attendance. So Amar has already shared it with you. So please mark your attendance and get super excited because we will be doing amazing use case for tomorrow, right? So again, bye guys, once again, and see you tomorrow.
Team, please mark your attendance. I shared in the chat box, and there will be the wind up the session.
Guys, Amar has already shared with you attendance. Those who are not got it, please refer to the comment chat box. Amar has sent it again, guys. Please take it from the chat box.
Okay, so thank you so much, all of you, for joining the session. We'll meet you on tomorrow at same time. Okay, bye bye. Have a nice time.